Congruent figures. Two figures are congruent if and only if they have exactly the same size and shape. And if that is true, the corresponding parts will be congruent. For example 1, we have a picture of two triangles that are congruent to each other, which means that all the corresponding parts are going to be congruent. The corresponding parts are going to include the angles and also the side links that we have here. All right, so angle A has a single marking. That is going to match angle F, which has a single marking. B has a double marking, E a double marking, and then C and D each have triple markings. So all of those angles are going to be congruent to each other. In addition to that, side AB has a single marking on it, and EF also has a single marking that would be on that. Likewise, for the other sides, you have a double marking here, and you have a triple marking here, which matches up to the other figure. And one more thing about that. The single marking is going to be between A and B, which has the single marked angle and the double marked angle, and that's going to be the same thing that we see over here. Between F and E, which has the single and the double marked angles there, that also has the single marked side. That would also be true for the triple marked side and the double marked side. All right, what we're really asked to do here is write a statement of congruence. The trick to doing that is to make sure that when you write the names of the two shapes, that you write them with all the corresponding parts in order. Okay, so for the first one, we'll just make that alphabetical. Call that triangle ABC. All right, so triangle ABC is going to be congruent to the other triangle, but since A with the single marking matches F, we actually need to start with the letter F. B has the double marking, so that's going to match E. C has the triple marking, so that's going to match D. Okay, so I want you to pay close attention here that this was alphabetical. We did A, B, C, but the other one was not alphabetical. You can't just call it D, E, F. It's important that in these congruent statements, the letters are matching up as the corresponding parts. Also, as an example, AC, which has the double mark here, needs to match up to FD. And we can see that in the statement. AC is the first and the last letter. FD is going to be the first and the last letter as well. Okay, so we need to make sure that we get everything written to match as far as the corresponding parts. One of the benefits of this is that if you were given a congruent statement, then you will already know which parts match. Like without even seeing the picture, I can be confident that angle B is the same size as angle E. All right, notice that there are multiple ways to write the statement. You don't have to do A, B, C. If you change up the letters here, you could do BAC. All right, as long as those letters go around the figure, which in a triangle they always will. Okay, I got BAC. Okay, so you do need to move around the figure. In a triangle, you can literally go any direction, start with anything. All right, so if we call it BAC, that would be congruent to triangle. Let's see, B is the double marked, E is the double marked, so you can start with E. A is the single, F is the single, and then that would leave us with D right there. So this would be just as good as a statement that we have here. As mentioned before, if you're given a congruent statement, you can actually use that to help answer questions. For example 2, we're given a diagram of two figures and a statement of congruence that goes with it. What we're asked to do is to figure out X and Y. All right, so one approach that you could take at this is you could imagine rotating or possibly flipping a figure to match up all the corresponding parts. And in this case, I don't think that that would be a bad idea. You can probably figure out that GF is the same thing as QR because they're the longer looking sides. You can probably also figure out that the angle that we have here, the 68 degrees, best matches Q just because of the general shape of the figures that we have here. However, using the congruent statement, you can actually use this to match things up. Let's go ahead and take a look for an expression here. QR has the expression 2x minus 4, okay? So 2x minus 4. QR are going to be the third and the fourth letters in that part, which means that it's going to match the F and the G, which would be the third and the fourth letter there. All right, so if I go to the other figure, FG is that length over there, which earlier I had already identified as probably matching, but this does confirm that, so FG is 12. We can set that equal to 12 and then just solve that equation. Go ahead and add on 4. We get 2x is equal to 16. Divide by 2, and x is equal to 8. So we got that one. All right, so where is y? Here's y. y is inside of angle Q. All right, so we got 6y plus x, but we just figured out that x is 8. Q is the third letter, and F is also the third letter, so F being 68 degrees is what we can set this equal to. Go ahead and subtract the 8. We get 6y is equal to 60. Divide by 6, and y is equal to 10. All right, so again, you could probably match up the different parts by just rotating the figure around, but you also have the option that you can just refer to the letters. So if you come across a figure where it's not so obvious, just go ahead and base your decisions off of the congruent statement. All right, let's go ahead and write a proof here. What we're asked to do is prove that these two triangles are congruent. Prove that triangle ACD is congruent to triangle CAB. Now, to do that, we actually need to prove the definition of congruence, which is that all of the corresponding parts are congruent. That means for us, we have to show that all three of the angles in one triangle are congruent to all three of the angles in another. We also need to show that all three sides in one triangle are congruent to all three sides in the other triangle. All right, so let's go ahead and take a look at the outline to the proof. You're going to notice that we actually have 7 steps in this one. We have a lot of steps that are here. And the reason for that is because to prove the definition of congruence, we need to actually show 6 things are congruent, 3 sides and 3 angles. Okay, and that's going to take up the first 6 steps. Step 7 is going to be that conclusion part. That one's going to be where we learn that triangle ACD is congruent to triangle CAB. Okay? And I'll go ahead and write that last step in here too. What we're going to say is the definition of congruent figures. Okay, the definition of congruent figures is that all the corresponding parts are congruent. So if we can show that in the first 6 steps, that becomes our definition and we're done. All right, so let's look at what we do have. A bunch of stuff is already filled in here because at the very beginning, you're told a lot of information. These are all given. These are all given things to you. AD is congruent to CB. In the picture, that would be right here. AD is congruent to CB. They both have the single markings. DC is congruent to BA. Those would be the double markings. Angle ACD is congruent to CAB. So ACD, that's the double marking, is going to be congruent to CAB, double marking, and CAD, single marking, is congruent to ACB, which is also our other single marking. So all these are given. All right, and then it is up to us to figure out the 2 remaining things. We need one more side. Well, we need one more pair of sides. We also have to get one more pair of angles. Let's go ahead and tackle the side length that we need to show to be congruent. The 2 triangles, the way that they're positioned, being side by side, they actually share a side here, which is AC. So we already know that the single marks match, the double marks match. The third side of these actually has to be the same length for the 2 different triangles because it literally is the same line. And that is what we call the reflexive property. We can say that line segment AC is going to be congruent. All right, before I write this one, AC, if I'm talking about this triangle, because if you notice, everything on the left here refers to that triangle and everything on the right refers to that one. So if I'm thinking about the one on the left, AC goes from the single marking to the double marking. So for the other triangle, we got to go from the single marking to the double marking, which would be CA. Okay, this is still the reflexive property. We're still talking about the side being the same as itself, but for the sake of structure, these letters are actually going to be flip-flopped to be corresponding. All right, 6, what we need to do is figure out the last angle. That would be angle D and angle B. Those 2 should be congruent. Now, the reason that we know these are congruent is because of the 180 rule. Triangles have to add up to 180. So if both of these already have a single marking and a double marking, and all that's the same, the third angle in each of these needs to be congruent. And we actually call that the third angle theorem. It is an extension to the triangle sum. If you have 2 angles of 2 triangles that match up, the third angles have to be the same size. All right, so that'd be angle D and B. And for those, you can actually just write angle D is congruent to angle B. You don't need to use 3 letters because it is obvious which of the angles we're talking about.
Later, blah.